This is pre-AP calculus. We're looking at our second example of given a function to be able to graph this rational function. This is the third video in notes section 5.5. What's the equation of the function in completely factored form? The numerator is already factored. It's the binomial x plus 2. The denominator is going to factor into an x plus 2 and an x plus 4. Just some things that we know out the get-go. This has a horizontal asymptote at y equals 0 because the numerator is a bigger degree than the denominator. I said that backwards. The degree of the numerator is less than the degree of the denominator. I think I said that backwards. The degree of the denominator is bigger than the degree of the numerator. This has a y-intercept of a fourth because 2 divided by 8 is 4. Those are the constants. This has a hole at x equals -2 because x plus 2 is a canceling factor in the numerator and denominator. This has a vertical asymptote at x equals -4 because x plus 4 is a non-canceling factor in the numerator. There are no non-canceling factors in the numerator, therefore this does not have any x-intercepts. So this would be 1 over x plus 4, and then there's going to be a hole in the graph at -2 something. I'm just emphasizing this right here. I didn't write it for the last problem because if the numerator is gone by division, it means there's a 1 left. Just wanted to make sure that's clear. If any, identify the vertical asymptotes. Explain how you know the vertical asymptotes. Well, x plus 4 is a non-canceling factor in the denominator. Therefore, g of x has a vertical asymptote at x equals -4. Does the function have any holes? Explain why or why not. What are the coordinates of the holes? Well, we have a canceling factor of x plus 2 from the numerator and denominator. Therefore, g of x has a hole at -2, and to find the y value, we're going to take what's left of g and put a -2 in for the x. We're going to get 1/2. If any exist, identify the horizontal asymptotes and how you know that you have one. The numerator and denominator, well, I just copied and pasted this. This should be different. The numerator has, how do I want to write this? Has degree, sorry about this, less than the denominator. I typed out some foolish stuff there. How about that? The numerator has a degree less than the denominator. Therefore, g of x has a horizontal asymptote at y equals 0. What are the zeros of the function? So there are no non-canceling factors in the numerator. G of x has no non-canceling factors in the numerator, therefore g of x has no zeros. I should have spent a little bit more time when I typed that out. What's the domain and range of the function? I gave you an answer in interval notation. Well, the domain is everything from -infinity to infinity, but you strip away any x values that are excluded. We have an excluded x value of -4 and -2. So we're going -infinity to -4, skip over -4, go to -2, skip over -2 and go to infinity. What's the range? The range is going to go from -infinity to infinity, skip over the y value of any horizontal asymptote or hole. We're going to skip over 0 and 1/2. Sketch a graph of this function on the grid to the right. You need a minimum of 8 points, 4 for each branch. I highly recommend putting on the asymptotes first. We had a vertical asymptote at x equals -4. That's going to be right here. We had a horizontal asymptote at y equals 0. That's going to be here. We can make these pop a little bit more. I like it when things pop. So this is y, whoops, I don't want that. This is y equals -4. This is x equals 0. So what else do we have? We had a y-intercept of 1/4. That's pretty close to 0. We had a hole at -2 1/2, which would be right here. And we had no x-intercepts. I don't think there's any other point that I'm missing. So if we make a little chart, XY chart, table, we got x values, and then we have y values of 1 over x plus 4. So let's see, what if we took negative, because right now we have no idea, is the graph up here or is the graph down here? Over here we know it's got to be up here because of these points, so it couldn't be down here, it wouldn't be a function. So I guess I'll do this first, give me an idea what this looks like. If I were to put in like a -1, for example, this would give me a 1/3 for the y value. So at -1, 1/3, that's bigger than a 4th. Not quite as big as a half. Say I put a -3 in, so that would be 1 over -3 plus 4, that's going to be 1. So at -3, it's going to be 1. If you need more points, put more points on. This is going to be this type of a shape, where as we continue left and right, this graph is getting closer and closer to the horizontal and vertical asymptote. I have no points for here, so let's throw some numbers in here. Let's do -5, whoops. Let's try -5, -6, -7, and -8. If I put a -5 in, we're going to have 1 over -5 plus 4, that's going to be -1. Put -6 in, we're going to have 1 over -6 plus 4, it's going to be -1/2. If we were to put -7 in, we would get -1/3. We just keep getting closer to the horizontal asymptote. If we put -8 in, we're going to get -1/4. So hopefully you can see this give you a good enough idea of what's going on here. If it doesn't, add some more points. Oh, and that's all wrong. All fiddlesticks. These are all negative, and I put them as positive. The shame and horror. The shame and horror. -5, -1 is down here. -6, -1/2 is right here. -7, -1/3 is right here. -8, -1/4 is right here. So my apologies for that fiasco. That was embarrassing for everyone. I brought shame onto my entire family. There's no x-intercepts, so we don't have to worry about that. We got this y-intercept hanging out here. Sure looks like that could be a 1/4. All right, that concludes these notes. Please do the homework that accompanies this.